I'm Laura Federico. I'm a science lab teacher for 3rd, 4th, and 5th grade in Chattanooga, Tennessee, and this is my lab that I do with my 5th graders when we study World War II. We do a lesson on the periodic table, just a brief introduction, and the role that Oak Ridge, Tennessee played in the Manhattan Project. We start the lab by just taking a look at the periodic table and how it's arranged, with 1 here, 2 over here, and talk about how the atoms, as they go up in size, the atomic number increases, so the atoms appear larger than the atoms that we start with. Just very brief introduction. And then I give them a lab sheet where they have to look for 3 elements named after planets, because we're going to talk about uranium and plutonium, so I definitely want them to look for those. And then just for fun, 2 elements named after places, 3 elements for which the symbol doesn't match the name, and then they're going to write their name using the periodic table just to have them look around for fun. So I show them that my name, Laura, is number 57, lanthanum, I think, 92 uranium, and 88 radium. Take about 20 minutes to do this. Here I've made up the name of a student, Emily Smith, and you can see that some names are more challenging to work with, but the kids still like looking around the periodic table trying to find letters that will work, and my goal is just to familiarize them with some of the elements. And then I have them answer the question the periodic table is like. And some will say an alphabet, because you can mix things together different ways and get different meanings, compounds that do different things. Or it's like a pantry full of ingredients. You could take the same 5 ingredients and make different things with it. You could make bread or cake if you had the right ingredients. This year, several kids said that the periodic table is like Minecraft. It's a video game, and because you take things in the game and you combine 2 things to get a third thing which is somehow related. The example one kid gave was if you put a pumpkin and a torch, pumpkin plus torch equals jack-o'-lantern. And you can create a jack-o'-lantern if you have those raw ingredients. So I thought that was pretty good. Each table is given a cup of uranium straight out of the ground, which of course is just sand. And they figure that out right away, although a few say, really? And we talk about the fact that grains of sand are much larger than atoms, but pretend that each grain of sand is a uranium atom. Most of the uranium that comes out of the ground is uranium-238, and we've already looked at uranium on the periodic table. We saw that its atomic mass was 238, but the uranium that they were isolating in Oak Ridge was uranium-235. So just to prove that it's there, I sprinkle colored sand on top, and I have a lot of these timers from some math unit that somebody was getting rid of, so I just break them open and dump the sand out. So again, it's still sand, but it's slightly different. It's pink. And so then they have to mix that in. So and I tell them this is what came out of the ground. It is less than 1%, the pink sand. But that's what we have to get out. So once I've sprinkled it on top, I've told them the difference. They mix it in, and then I say, okay, now separate the pink sand. Separate the uranium-235. And they look at me like, how in the world could we do that? And they try several different methods. I've had kids ask for a balloon and rub it on their head and try to get it out that way. They've asked for sieves and coffee filters. They pick through it with magnifying glasses and pencils, which is usually the way it works. And then we discussed the fact that at Oak Ridge they tried several different ways to extract the uranium-235 isotope. And I do throw in the word isotope, although it's certainly not a 5th grade standard. I think it doesn't hurt them to have heard that word. The purpose of the town of Oak Ridge was to create a facility to separate the uranium-235 atoms that they needed for the nuclear weapons from the regular uranium-238. And this was a billboard found outside the gates to the facility of Oak Ridge, instructing employees to keep everything secret. The town started with a population of around 3,000, and within 3 years there were 75,000 people living there. There's a great map of places around the country that were somehow involved in the Manhattan Project, either mining uranium, or developing the aircraft to carry it, or isolating the uranium isotopes or plutonium. And you can click on each one and it will tell you a little bit about those places. The website for Oak Ridge, the Wikipedia page for Oak Ridge, goes through the population of the town, things that were built, people coming and going from work. And again, the Manhattan Project, it talks about when they are trying to separate their uranium-235 atoms, which is the pink sand, they keep saying, how do we do this? And at Oak Ridge, we actually tried 3 different methods. There was a Y, from what I understand in my reading, there was the K25 plant, the Y12, and the S50, and they all had different, they were all trying different methods to separate the uranium to see which one worked out the best. Final part of this lesson, we discussed the fact that these were fission bombs. They were large atoms that split, and that released energy. So I mix up a batch of salt dough, and I give the kids each a fist-sized ball of this dough. So here's our uranium atom, and when I count down with the kids, they're going to split it. Every kid has a piece about this size, about as big as your fist. And we've just finished pulling out the uranium, so this is their uranium atom, and we are going to split it when I count down from 3. But I never count straight down. I'll say 3, 2, now where was the place they separated this? And they all yell, Oak Ridge. And then we count down again. 3, 2, what was the name of that project that was focused on making nuclear bombs? Manhattan Project. 3, 2, what isotope is this? And we go on like that a few times just to build the suspense. And then finally we count down 3, 2, 1, boom, and split the atom. After we have demonstrated fusion with our big atom, then I have them take 2 very small pieces. These are hydrogen atoms. And once again we go 3, 2, now where does this occur? On the sun. 3, 2, what are these 2 atoms? Hydrogen, and so on, until finally 3, 2, 1, boom, even louder than we did before. And that's fusion. And both give off energy. As a formative assessment at the end of this part of the lesson, we do a Venn diagram comparing fission and fusion, and we talk about things like the boom that came from both of them, the energy, and that both are considered nuclear energy, but that fission is splitting larger atoms, whereas fusion is fusing smaller atoms. Fusion starts with hydrogen, fission with uranium or plutonium, and so on. So this is how we wrap up our discussion. So we started with science and the periodic table and isotopes, and then we studied some history that was related to our topic in a place that's not too far from where we live. And then we come back to science again at the end and our overall topic of energy. Again, I have used this lesson with 5th grade because they study World War II. They also study energy and the planets, and so we get back to the fusion with the sun sort of as a reminder during this lesson. I would certainly use this lesson with 8th grade, though. They study the periodic table in 8th grade in Tennessee and a lot of chemistry. They study U.S. history, but they don't make it as far as World War II. But still, this would be an appropriate lesson to use with them, and gets at some engineering standards with nuclear power.